Hi friends, so in this today's session we are going to see some of the definitions. Here we are going to see the definition of force transmissibility, motion transmissibility, damping ratio, logarithmic decrement and magnification factor. The first definition that we are going to see is of force transmissibility. Now, the transmissibility means whenever there is a vibrating body, then that vibrating body will transmit its vibration to its support. Means the vibration will be transmitted to support, means the displacement of vibration is also transmitted and the force in the vibration is also transmitted to the other machine. That is nothing but the transmissibility. So, we will see this force transmissibility with example. Consider there is one support. On this support, there is another one system having mass, spring and damper. Suppose this support is having displacement y, and that is equal to y sine omega t, means it is vibrating with SHM, and the displacement of this one means this spring mass damper system is x. It is also vibrating with the SHM, so its equation will be x sine omega t. This capital X means amplitude. Now, whenever any system is going to vibrate, ultimately it will transfer its vibration to the support. Means this support will start to vibrate with the displacement y. When any system starts to vibrate, then these vibrations are because of the unbalanced forces. The force which is acting on this system, I will consider this force as F0. So, this F0 force is acting on the system, and because of that this system is vibrating. Then this force will be transmitted to this support, and the force which is transmitted to this support will be Ft. Then the force transmissibility is defined as it is the ratio of force transmitted to support by force impressed on the system. See here, the Ft is the force transmitted to this support because of the vibration of this system, and the unbalanced force means force impressed on this system is F0. So this transmissibility is equal to Ft divided by F0, and it is given by a formula. This formula we have used in the problems also. This formula is, first I will show you the formula, then I will tell you how to remember this formula. This formula is 1 plus 2 zeta omega by omega n square divided by 1 minus omega by omega n bracket square in whole term square plus 2 zeta omega by omega n square. So this is the formula for the transmissibility of force. Now, how to remember this formula? Just see this denominator that you know, this denominator you have used in the first vibration to determine the amplitude, and in that amplitude this is the denominator that we have used. So just we have to change the numerator of that particular amplitude. Here consider this first term as 1 and keep the second term. Okay, so consider first term 1 and keep the second term, we will get the formula for the transmissibility. And what is the definition of transmissibility? It is the force transmitted to support because of impressed force on the vibrating system, that is F0. So it is the ratio of Ft by F0. It is nothing but the force transmissibility. Similarly, we can give the definition for the second term, that is the motion transmissibility. Consider same system. Now instead of force we are going to consider the displacement. See, this system is vibrating with displacement x. Then this displacement x and the vibrations of the system will be transmuted to this support, and there will be vibration of this support, and this support will vibrate with the amplitude capital Y. So the transmissibility, that is the motion transmissibility, is nothing but the ratio of x by y is equal. Now here suppose the support is vibrating, and because of that this system is vibrating, then we can write x divided by y. Or suppose this system is vibrating and it transmits the vibration to this support, then we can write here y divided by x. Now this ratio x divided by y means this is the displacement of the support, displacement of the vibrating system is equal to, the formula is again same. It is 1 plus 2 zeta omega by omega n square divided by under root 1 minus omega by omega n square whole bracket square plus 2 zeta omega by omega n square. Okay, so this is the formula of motion transmissibility, and the definition of motion transmissibility is, it is the ratio of amplitude of vibration transmitted to support divided by amplitude of vibration of vibrating body. Okay, so this is the definition of motion transmissibility. Now we'll see the third term. The third term is the damping ratio. See, this damping ratio, first it was introduced in the vibration in the derivation of, in which derivation? In the derivation of damped vibration, and in that damped vibration, we have used this damping ratio. It is the ratio of damping coefficient divided by critical damping coefficient. So suppose in this system the damping coefficient of this system is C, then there is one value of this C such that at that value in the derivation of damped vibration, the solution which is coming of S1 and S2 becomes only 1. Means there is only one solution for damped vibration, and at that particular value, when we are going to get a single solution, the C value becomes Cc. So you can write, it is the ratio of damping coefficient divided by critical damping coefficient. Now depend upon these values of C and Cc, there are three different of damping systems. The first one, under damped system, if this zeta is less than 1. Second one, critically damped system, if zeta is equal to 1. And third one, over damped system, where this zeta is greater than 1. So damping ratio or damping factor is represented by zeta, and it is the ratio of damping coefficient of system to the critical damping coefficient of system. Now the next term that we'll see, the next term is logarithmic decrement. So the fourth term is the logarithmic decrement. See, in the earlier videos I have uploaded the derivation of logarithmic decrement, and in that derivation we determine for a underdamped system logarithmic decrement. So suppose this is the graph of displacement with respect to time for one system. So suppose this is the displacement and this is the time. Then because of the damping, the initial amplitude is x naught. After one cycle, here you can see the amplitude is reduced and that is x1. Then for next cycle again the amplitude is reduced and it becomes x2. So in each cycle the amplitude of vibration is reducing because of the damping. So the logarithmic decrement delta, it is given by log to the base e x naught by x1. So the definition of this logarithmic decrement is, it is the natural log, that is log to the base e, it is the natural logarithm of ratio of two successive amplitudes. Means it is the ratio of x0 and x1. So these are the two successive amplitudes on the same side. See, again I will repeat the definition. It is defined as natural logarithm of ratio of two successive amplitudes on same side is the definition of logarithmic decrement. Okay, now we'll see the last term. The last term is magnification factor. So the fifth one is magnification factor. Now to see the magnification factor, we'll have to use forced vibration. So in the forced vibration, the amplitude of vibration is given by f0 by k divided by root 1 minus omega by omega n square bracket square plus 2 zeta omega by omega n whole bracket square. This term is omega. Okay, and this is the formula for the amplitude in forced vibration. Now this f0 is nothing but force impressed on the system, and that is the maximum force divided by k. So if you know the stiffness, then stiffness is nothing but force divided by displacement. So ultimately displacement is equal to force divided by stiffness. So here we can see it is the formula of force divided by stiffness. So I can replace this term by xst, means maximum force applied to forced vibrating system divided by its stiffness, and that is represented by xst, and this denominator will remain as it is. So I have modified the formula for amplitude of forced vibration by replacing f0 by k. Okay, and that term is xst. Now transfer this xst to this side. So x divided by xst is equal to 1 divided by this root. Okay, now we will come to this magnification factor. This magnification factor is nothing but the ratio of, the magnification factor is nothing but the ratio of x divided by xst. It is the ratio of x by xst is called as magnification factor. So it is the ratio of amplitude of steady state vibration to the zero frequency deflection. Now why this is called zero frequency deflection? Because actually in forced vibration the force is F naught sin omega t, and we have considered sin omega t is equal to 1. So this is called zero frequency displacement. So it is the ratio of x divided by xst is nothing but the magnification factor. Okay, so the students asked me to give the definition of these 5 terms, so I have taken these 5 terms for the definition. Okay, so I quickly revise all the terms. First one, the force transmissibility. It is the force transmitted to the force impressed on the system, and it is represented by TR. Next, motion transmissibility. It is the amplitude of motion transmitted to support divided by amplitude of vibrating system is the motion transmissibility. Third, damping ratio. It is the ratio of C by Cc, that is damping coefficient divided by critical damping coefficient. Next one, logarithmic decrement. It is the natural log of ratio of successive amplitudes is the logarithmic decrement. And the last one, magnification factor. It is the ratio of x by xst, and this ratio is nothing but the magnification factor. Thank you.